My name is Hadi Nahari. I'm Principal Security Architect and Mobile Architect at PayPal. I have committed the design of the mobile products. I'm here to talk about mobile payment security versus usability. So mobile payment used to be oxymoron. Security and usability still is oxymoron. So believe it or not, Osama said PayPal started mobile payment back in 2005. It's not actually exactly true. PayPal started as mobile payment. So here's what happened. The original people from PayPal go to the venture capitalist here and say, we have this great idea. We want to perform payment using SMS. And the VC said, you got to be crazy. You got to be out of your mind. Go ahead and do it on the web. This is how PayPal started. So fast forward right now. This is what we are doing right now. Security versus usability. So I'm going to talk about how to manage security and usability. This used to be a biggest oxymoron, biggest thing that you have to give away security if you want to do usability. Let's see what we can do to cover this so we don't give up security for usability or vice versa. So my agenda is very simple. I'm going to talk about usability. What is usability? How we define it. Can you guys hear me well? Yeah. And then talk about mobile payment or M-payment, M-commerce, and why that's important. I think it's beating the dead horse, but it's worth to see a couple of numbers. Security and make security and usability at the same time. That is not a typo for people who are not developers. That is double ampersand. And then conclusion. So how many people really hate security? It's absolutely pain in the sensitive areas, right? It's really bad. So how many people really hate to be the victim of identity fraud? Isn't that ironic? You hate something that prevents you, protects you from what you hate to have happen to you. OK, so let's start. I love these questions. So usability. What is usability? The source of truth, Wikipedia. Usability is the study of ease with which people can employ a particular tool or other human-made object in order to achieve a particular goal. So it's about ease. It's about goal. And ease is something that is very subjective. What is easy for me should be may not be very easy for you. But the goal is something that is subjective. It's theoretical. It's something that is practical, tangible. You could define it. It's the area of the software, right? So users really don't care. Is it theory? Is it practice? Is it subjective? Is it objective? They need to be able to use it. So that is the definition of usability. I really love that quote from the Chip Morningstar. By the way, it's one of my favorite quotes. So when we deal with usability, we are talking about things that are very, very difficult to measure, very difficult to accomplish. And it's in the hands of people who are not really experts in the field, but they call the shots. I love the questions that we used to get back in early days of Valley, that when something broke in our software, I was at Netscape in those days, people would come to us and they would say, what did I do wrong? Now, if something is broken in the software, it's like, what's wrong with this? So they call the shots. I love that. This is good. We're doing a good job here. We are delegating control. We are delegating judgment to users, and that's the right thing to do. For computer scientists, it's a bad idea, but I think it's a good thing to do. All right. Examples of usability. Extensible design. What if this building just sinks? You should still be able to get out of it. Functional. Your objective is you want to cut the damn grass. Functional. Conceptual. It's about air and bag. Love it. Literal reading of the term. I love this one. See, you could turn it on. What if the user wanted to turn the damn thing off? So think about it. My favorite example. This must have been a software engineer. This is a legacy system. You achieve the functional description based on what you have. Your product manager says, oh, no, you can't build it. We got time to market. You got to deliver it. This is what you end up with. This is a phone. Trust me, it is a phone. I'm not going to say it's from Japan, of course. It's got that camera. But it's a phone. My favorite. When the Bluetooth fails, this is what happens. All right, enough of that. So, M-payment, mobile payment. This is what a financial institution does. 4 things. Number 1, dealing with regulatory issues. Compliance, tax, PCI, payment card industry, PADSS, data security, the legal stuff. Those are the very traditional things that when you deal with the money or when you deal with the value, you deal with these sort of things. The next thing that a financial institution does is money movement, the mechanics of moving money from one account to another account, performing tax, billing and settlement, and routing of those values. Identity management, you want to make sure that the correct identity, the right identity, is in charge of sending or receiving. That's the part of identity management. Risk management, where technology meets the dollars. This is the black art. This is the secret sauce of any financial institution. So the online payment is very similar, except that the adage of cash is dying becomes the cash. The war is on cash, not on cash. With C-A-C-H-E, I could read, yeah. Okay, so here's the thing, observation. The lower you come, the closer you come to the land of technology. The top parts, the legal, regulatory stuff, the money movement, all those things are mechanics. The lower you come, the notion of identity management and risk management, the closer you come to the field of technology. So let's see how that plays in the usability. So risk management, RM, these are the challenges of risk management. So the risk-driven decisioning, these are decisions that you make based on authentication, authorization, based on the stuff that you get from devices, from users, from technology, from everything else, is very important. It's highly time-consuming because it's data-driven. Most risk models require a great deal of data to capture, great deal of data to work with. It's not easy. It doesn't happen overnight. You have to have a huge amount of data to be able to make risk decisions that are meaningful. And you have to have incurred a lot of losses. You have to pay those, you have to pay those monies that the users have lost to make sure that you capture the correct and usable data. The problem is none of these risk decisions, risk models, are local. What that means is the risk models that, for instance, PayPal has is not exactly similar to the risk models that Visa has, MasterCard, and others have. You cannot just go ahead and interoperate, share those data. This is the secret sauce. What that means is for the application developers to try to manage this in the applications and also provide a usable experience for the users, it's a bad idea. I'm building the case for what are the things that is a good idea to do in the application, closer to the users. What are the things that you should do closer to the back end, like PayPal? So, and payment, the current next big thing, it's a very close variation of traditional payment. So in traditional payment, when I say traditional right now, I'm talking to online payments. How many people go to banks to deposit their checks once a week? Once a month? Once in a quarter? So this question had a different answer 5 years ago. What that means is everything's coming online. The next thing that is happening is everything coming to your mobile device right here. Beating the dead horse again. So the infrastructure things that you got to do to perform online payment mainly is very similar, very close to what you need to do for mobile payment. So you don't need to create a fundamentally new infrastructure. A lot of things are the same when it comes to the mechanics of money movement, but there are things that you got to do that satisfy the mobile payments. but it's not fundamentally a separate system. Consumers are ready to pay. I'll let you read those numbers. You could read yourself. The one observation, take a look at the numbers on the web, the portion of monetization on advertising and e-commerce and paid services on the web, and compare those with the numbers in mobile. You see that e-commerce on the mobile, or m-commerce, 73% within the past, I think the data is for the past year and a half or 2 years. There's an interesting observation to be made. Something has happened within this period because e-commerce existed for about, about 15 years. We had this notion of Corba. We had this notion of physical goods. eBay existed. All those things existed. But something happened in mobile that people became very interested in performing mobile transactions. Take a look at these data. That something, by the way, is this usable device. Call it smartphone. I always say it. It's actually a very stupid phone. When you want to perform phone functionality, drops the calls and everything. How many people here have iPhone? How many people have iPhone and Android? How many people have more than 5 devices? Come on, there's got to be more of us. All right. OK, so take a look at this. There is a correlation between usability and the usage patterns. You see those numbers? There are some entities there. Web OS. Remember those devices with the Web OS? Remember the operating system that's called Symbian? It's dying. And remember that there's these 2 big players, iPhone and Android. These are taking up a great deal of the operating system traffic, the usage of the operating systems. These happen to be the 2 most usable operating systems. Whoever has done application development on Symbian knows what kind of arduous experience that is. Brings tear to grown-up eyes if you want to have a usable application on Symbian. It's terrible. iPhone and Android, you can have your own opinion about the companies or their idea, but they are a lot more usable than most of these operating systems. So my assertion here is the reason they're picking up a lot of users is not because all of a sudden people love this company, Cupertino or Google. It's because these devices are more usable. Another data point, you see that share? iPhone OS has got 67% of the mobile web traffic. There is a correlation between that and the usability. The point is, the more usability you add to your application, the same user who were acquainted to using these applications on the web become more useful, become more acquainted to using these applications on their mobile phone for something very easy and simple to understand. You carry this device far more frequently. You check it far more frequently than your laptop. Just makes sense. So web traffic is also a linear function of usability. OK, security. I'm not going to ask that question again. My Mythbuster. I love this program. You guys watch Mythbuster? Yeah? It's cool. OK, so security means different things to different people. Absolutely. Can I say BS here? Absolutely BS. It's not. Whenever you have something that you need to protect, the mechanism to protect that thing, we call that thing security asset, is security. No one disagrees with this. This doesn't mean different things to different people. Now, what you protect and how you protect it is different. But the security itself is not different. Number 2, closed source is more secure than open source. We have theoretical concept about it. It's called Kirchhoff principle. That is, if the security of your application or your protocol relies on the secrecy of it, it's not going to work. It's called Kirchhoff principle. So it doesn't mean that closed source is more secure than open source, except there is one exception. I think there is one. Who knows that exception? Except you're NSA. Then you could afford, because you got the best cryptographers on face of the planet, you could afford make it secret. But for the rest of us, closed source doesn't mean that it's more secure than open source. Security could be achieved by obscurity. No. You can't go ahead and hide part of your password in one piece of the code, part of it in other piece of a code, and think that it's going to be secure. You cannot obscure and achieve security. That's got to be a good exercise. Software-only security is good enough? No. Depends what you want to protect. We're going to talk about it a little bit later. But technically, when you have software-only security, by definition, you could open your application and open your logic to what is called system-wide attacks. One piece of software could tackle all the instances of your software. One piece of attack could tackle all instances of your software. Security staff are pain in the tushy. We are a viable form of life. We are not that bad. Security is a set of components. No. It's like this is a security component. You have designs that take security. It's like performance. You cannot go ahead and design a system, implement your software, and then go ahead and add security as a component to it. It just doesn't work like that. It's part of the philosophy. Can protect against all the attacks. That's a good one. It's one of my interview questions usually. It's, can you protect against all the attacks? No. Why? Because you cannot enumerate all the attacks. If you have 1 meg data, only 1 meg data in your cache, the combinatorial explosion of all the possible combinations of data in that 1 meg is 2 to the power of 1024 times 1024. You can't go ahead and take a look at this vision of the memory, this view of the memory, and decide this one is secure, this one is not secure. Therefore, you can't protect against all of that. Theoretical crap. Encryption equals security. I have SSL in my software. I'm secure. Fun, eh? Yeah? No, encryption does not equal security. Encryption could help security. Some of my friends mentioned that this is one of the typical fallouts of the security design. You cannot just add security. Encryption is the easy part. It's very difficult, but it's the easy part. But by just adding encryption or SSL, you can't claim that you have accomplished security. Moving on, we'll add security later. No, you start from scratch. And people underestimate the intelligence and the knowledge of hackers. Last time I checked, these guys were really smart. I forgot who said this. I remember. It's like it takes twice as much effort to debug a code than to write it. Therefore, if you debug your own code, by definition, you become twice as intelligent at the same time. My assertion is it takes twice as much to break a good code than to debug it. So by definition, a hacker is 4 times smarter than someone who wrote the code, just to start with. So morale, hackers are not stupid. How am I doing so far? Okay. Okay, you're with me? Cool. All right, so when you add security and mobile and the players, it is very complex. The message of this slide is those two components, the portal, the app worlds or the markets of the world, the application warehousing, and the MNO, mobile network operator. These are 2 new players for mobile security. The rest, they existed. The financial institutions, regulators, and retailers who basically provide you with the merchandise existed. But those 2 entities are adding. Whenever you add one more entity to any system, it makes it exponentially more complex. Therefore, protecting the system, moving money from one part to another part, carrying the things from here to there, becomes more complex. Those arrows are what we call security boundaries. There are many security boundaries that kind of explode. The more entities, elements you add to this ecosystem, the more complexity you add. Therefore, the more difficult maintaining security becomes. So in this model, it's a very complex ecosystem. We call it identity proliferation. Why? Each one of those entities identify you based on their own notion of identity. You are Matthew for Bank of America. You are user M-A-G, I can't pronounce your last name, something for PayPal. You are somebody else for your MNO. Each one proliferates your identity. And you can't go ahead and become one single identity. There are standards, OpenID and OAuth and everything that try to bring all of these together. But the fact remains each organization identifies you based on their own notion of identity. That's a bad news because you have to manage all of those. It's a heterogeneous identity scheme, meaning they describe you with different characteristics of you based on your bank account, based on your financial instruments, based on your email address, based on different things. So it's not the same thing. It's not just multiple things, multiple different things. It's the protection model. I'm not going to go through the theory of it. It's very complex. that is, I have job security. And all the above impact usability. If you want to provide a usable experience for your application in this model, it's very difficult. So you have to pick and choose. What are the things that you want to provide usability and security, and what are the things that you have to rely on a reliable party, say PayPal, for the payment. So what is secure and usable at the same time? What does the landscape look like? The landscape looks like something like this. So we call it security proportionate to risk. Remember, you have to pick and choose what are the things you want to protect. What is the criterion for you to make those choices is the risk. Risk in the financial environment calls the shots. Whichever is riskier and impacts your consumers, your clientele, people who use your application, use your solution, takes a higher priority. The more security you add, by definition, the more expensive it becomes. If you're NSA, DoD, and other entities that have unlimited or undisclosed money, you could afford creating a security that is absolutely secure or reasonably secure. But we are making money. So we got to make sure that we find that sweet spot right there where you could still make money. You tackle the 80-20, 80% of the most important security issues, and you still make money. That is a moving slide. What makes it move? What is something that is not risky today may be more risky tomorrow. And the attacks, remember, Bruce Schneier says, attacks only get better. Has anyone seen an attack that has gotten worse? It doesn't. Remember, hackers are not stupid. They make their attacks better. Meaning, over time, things that are expensive might become, based on the laws of economics, cheaper. Things that may not have been risky a year ago could have been a risky, or what we call security asset. You have to take that into account so you could accomplish a good, reasonable, risk-driven security. Therefore, your solution should be flexible and simple to provide that usability. If it's simple, it's easy to understand. If it's flexible, you could go ahead and juxtapose different parts. You could augment your authentication, for instance, add those sort of biometrics measures so that your authentication becomes smooth and catches up with the attacks. Do you have to be the best authentication, the best secure solution in face of planet? No. Remember the rule of Hungry Tiger? People know it? You don't have to be the fastest person. You just need to be the second slowest person, right? So that's how it works with the hackers. Unique challenges when you take a look at this paradigm on mobile is a couple of things on this device that are very unique. Makes it very difficult to create a useful, usable solution on this device. One of them is the real estate on the screen is smaller. Why does it matter? Because users' attention span is different. Typically, when you have a big screen like this or like that, you have a lot of things for your brain to play. You use the same application on your set-top or laptop or a full-fledged computing device. You spend 3 seconds. It may not look, it may not seem a long time. You wait 3 seconds on this device, you're going to go nuts on the same application because you expect it to respond quickly. That affects the usability design, the design criteria about usability on this device. Your attention span on the same device, on the same application, is different. The smaller screen, the more constraint you have to overcome. The input is very awkward. It's not just because I have fat fingers and I can't type. It becomes oat and all those things. It's sometimes you have a device like Xbox. It doesn't have those touch screens. You can't go ahead and take a look at the joystick to look, okay, so what is the next character of my password that's dash or ampersand, whatever, where is it? Doesn't have it. Or you realize that in the keynote that TV, T-commerce example, it had a pin because you have a remote. It's not a full keyboard. All you have is a remote. That's part of the motivation that we provide pin entry for your authentication. So the input is very important. Input is the first interaction that users have. with your solution, with your application. Over the air and the latency, users, you cannot just punish users to wait for things that are going over the air. Take a look at over the air, things that you have to go up, over the air, you have to communicate with the infrastructure. Deal with those as if they are a database. As programmers, we understand we don't store everything in database. We don't just go at every single time. What is the size of this box? Let me go retrieve it from database. We don't do that. You deal with the OTA. You deal with whenever you want to go over the air very, very similarly. You only go over the air in your application when it's absolutely necessary. You don't want to make the users wait. And the user experience design is very complex. You can't have 5, 6 different screens here. Okay, next screen is my address. Next screen is my picture and all that. You have to put everything in one, at least, at most 2 screens. Usability concepts. That applies to the authentication and authorization decisions as well. You can't just every single time that the user communicates with your application, interacts with your application, just go ahead and ask them to wait, I'm going over the air, I'm going to go ask PayPal. You can't do that. There's a lot of things that you have to embed in your application, and there are things that you should not. Let's see what those are. So you have to decouple authentication and authorization. Rule of thumb, it's just good software practice. It is not just true for security. Decoupling, loose coupling is a good thing, right? We love loose coupling because you could play, you could mix and match. You could go ahead and address the problems in the right place. You don't have to go ahead and read through the whole code and make changes in the entire application. You have to focus as developers. How many developers do we have in the audience? People who actually code. Good, so it's about 25%. So those guys know that you love to just focus on your application logic. You want to rely on somebody else to do things that you don't want to do, like risk management, things of that sort. All you need to do is you got to focus on application logic, bring the library or jar file or whatever services, you got to use those services. They have to be decoupled. They have to be provided to you. Same thing as the web, so we extend the same concept here. You don't want to harass users when it comes to security. Bad idea. What is your mother's maiden name? What was your mother's maiden name before she got married? Do you have more than one mother? Oh, let me see. Is it really you? I mean, you can't do that. There are, believe it or not, there are security solutions that provide this kind of harassment. The moment you're trying to capture that goddamn CAPTCHA, it changes, it expired. Okay, now, is it L or 1? I mean, it's like, you know what, screw it. I'm not going to use this site. I mean, with the name of security, we can't just go ahead and bang the users. And delegate risk management. Risk management as one thing that is important for us, for the financial institution, that is something that is very, very involved, very sensitive. You want to delegate those decisions to a party, to an entity that is in charge and it's really optimized to doing that kind of services. You don't want to get in the business of doing it yourself unless you have a lot of money and you can wait about how many years? 12 years. Why would you want to do that? I don't know. Go over the air, and over the air here is go outside your application to perform communication if it's absolutely necessary. Remember this. OTA is like database, sometimes worse. Usually, a lot of times, when you go over the air, that is the time that the users are impacted the most because they're waiting and they don't know what's going on. So those are the concepts that when you add, you're closer to marry that complexity with the usability that is useful and addresses the right problem, typically. Those are the concepts of the previous session, MPL, Mobile Payment Library, an instance of Mobile Embedded Payment, MEP, that we took into account as to what are the things that we could do so we could delegate some of these decisions, some of these functionalities to the backend so you as the developers get to acquire and use those. And one of the things that you could go ahead and use, provide you so you could use them. So once your application starts with the logic, goes through the logic, at the point that it enters the payment logic, we take over. We provide the trust of PayPal for PayPal users. We take over that function right there. We call this the monolithic model, that the application just delegates the payment, waits for the payment to go through, and then you go back to the application, continue with the application. This is the concept of making it usable as well as secure for your in-app payment experience. The concept is the same. It shows itself. You will see in the different products that PayPal has provided to the developer community in different facets, but the concept is the same. The things that you need, the way you need it, which is secure, doesn't compromise the security of the transaction or the identities of the users, at the same time providing payment capability to you, at the same time providing the services like risk management services from the back end to your application, through your application to the users. Remember PayPal? Secure, safe, easy. That is the concept here. That is the design concept for this. You could be fancy and say, hey, that's a monolithic model. What if I have 5 applications? I want to perform one-time authentication. Remember Osama mentioned that you authenticate on one application and then the rest of the applications on the same device don't need to do it. That's a good idea. You, as a user, you want to say, hey, you know what? I already authenticated to PayPal here, and then I want to bring the rest of the application. That's the driver of that is usability. The way to accomplish it is to expose some of these functionalities in a controlled way to you as to, I already authenticated. This is my authentication token. I want to reuse that for the rest of the applications so long as it's the same user on the same device. Or you could extend it by providing some of the account capabilities as to what if the user has got multiple accounts? What if the user has got multiple devices? What does it mean to have a series of devices that, from PayPal's perspective, belong to the same user? Those are the use cases that once you provide this granular model, you could go ahead and provide. How am I doing on time? Good? OK. But the concept from the backend and from those services are very similar. OK? So what we accomplish by doing this, by implementing this, by providing these kind of capabilities, just goes to the heart of security, as I mentioned, meaning your application focuses on the app logic. Your users see your application, interact with your application. They focus with that. The user performs authentication, and your application is authorized, is basically obtaining authorization. The rest of the stuff is happening in the back end. We provide that. Think of it this way. Instead of PayPal just receiving the user and the amount and then do all of those mechanics behind the scene and then give you a result, we're exposing those functionalities as not exactly as services for the mobile devices, as capabilities to your applications. You could reuse. You could take advantage of those risk, very black art, very capable infrastructure in the back end and still perform payment. This is one of the good concepts of providing usability at the same time, not compromising security. What is the term here? Is deoxymoronizing security and usability. So I want to leave some time, hopefully a lot of time, for questions and answers. And I don't want us to be, at least in my session, just sharing with you what I think. I would really love to hear what you guys think, especially if you're a developer, if you're looking on some solutions. Please come let us know. There's these labs. If you haven't attended this one today, there's another one tomorrow. Come let us know. I'm personally very eager to hear what you guys think. The Hadi concept is the number of smart people outside your organization is a lot more than the ones inside. So there's a lot of smart people out here. I would really love to hear from you. What are the things you would like to see? What are the problems that you see? Let us know, and I will guarantee that these will be heard. And with that, Osama said he had the shortest email address on face of planet. I have the shortest and the coolest email address on planet. I get 1,500 spam in an hour, about 30,000 per 24 hour. So if you really want to correspond with me, my PayPal address, but that is just a very cool email address. With that, I'll shut up, and I want to listen to your questions and hopefully provide response. Thank you very much for your attention. I really appreciate your time. Any questions? Let's use a microphone so the rest of the
So what are the underlying mechanisms in the transport and at the back end that ensure for security?
So a couple of things. Remember, the question is, what are the things that we do to ensure security? A couple of things. Right? Did I catch your question right? A couple of things. Identity management is a big thing. So we have part of the risk infrastructure is making sure that the user is who he or she claims they are. And the other thing is ensuring that the trustworthiness of the execution environment. That is different from one environment, one mobile execution environment to another one. The rules of engagement in iPhone operating system is different than the ones in Android. Security, potentials, credentials. Oh, okay. So there are two types of security credentials. One that are unforgeable, if you're familiar with the capability model. Unforgeable, but public. Things like, think about a public cert, X509 cert. So the moment that you touch it, if you want to change it, if you change it, it's detectable. That's public and unforgeable. The other type is private. May or may not be unforgeable. We would like to have it unforgeable. We rely on the first type, public information that are not unforgeable, that are not forgeable. So that is the notion of ID, meaning everything that comes from the device to the backend, we perform a lot of processing, and it goes through the risk model. One could think that if there were devices that had hardware security or more layered security, notion of layered trust, we would be able to use that. We can, but those devices are not really really common. What I'm referring to is the devices that have things like Trust Zone, MobiCore, things that have devices that have two execution environments. One of them is public, the other one is secure. You could do a lot of sensitive stuff like a secure UI, protected UI, which happens in a secure environment. Interacts with the user, gathers user and password and everything, but the rogue application cannot see it. Those devices do not exist. The moment they come in, we are already prepared and willing to use those. Does that answer your question? I'm having a hard time hearing the gentleman. Can you? SAML. SAML? So the problem with SAML, right? If the question is SAML, the problem is secure markup language, assertion markup language. The problem with SAML is SAML tokens, SAML assertions are really good, fine-tuned for the web. Each SAML token on average is about 70K. There is no way on earth I could go ahead and transfer that over the air. You have to wait for a 70K SAML assertion to wait here, verify the integrity, and then send it back to the server. We can't do that. However, we have something, I guess I could say that. We have something that has the idea of SAML, but is much more fine-tuned for the mobile environment. Again, that is something that in the backend we use. What the artifacts that you see, you shouldn't care whether it's a SAML artifact or it's a OAuth artifact or different types of assertions. You just provide the identity that the user claims to have. You rely on PayPal as, using that terminology, relying party, not relying party, the verifier party, to verify is it the right user. And we have the whole set of data. Is the payment corresponding to the history of the payment of the user, things of that sort. The risk comes to picture, meaning a lot of those things you could do based on the protocol and artifacts, or you could do based on the statistical models. That's the magic. And that is something a financial institution, I think, can do better than other non-financial institutions.
Are there limits to when you authenticate on your mobile device? Are there time limits or other limits to de-authenticate your device after you've authenticated? For example, if I lose my phone, I don't want it to still be authenticated to PayPal. Does it change authentication when it goes to sleep or after a certain amount of time or something like that?
Two sets of things. I'm assuming that you're talking about the authentication by the user, for the user. So
yeah, for the user, so you can use multiple apps and still be authenticated.
It's not as granular yet, so that I could de-authenticate or expire the authentication of one app, but still be authenticated to another app. That is a doable from technology. We haven't seen a use case that requires that sort of thing. But the authentication does time out. Some of that is in your hand. You could say, hey, you know what, when it's like more than 2 days or more than 5 hours or something, you could de-authenticate. You could expire. Some of those things are in the backend. Even if you go ahead and set it to like 5 hours, if we see some activities in the backend that are kind of smelly from the risk perspective, we don't honor the authentication. It doesn't really matter. It's the same thing. You go to your bank, you show your card and everything, and if it's like 25,000 transaction, they will ask for more assertions. We follow the same construct, the same model, but in the device and digital space. Does that make sense? Yes. I'm interested in those use cases, by the way. If you can think of some use cases that require some application to behave differently on the security perspective than others on the same device, let me know. Yes, sir.
Hi, I'm curious as how you advise or influence partners such as the security measures taken by your partners such as Bling, for example. How do you deal with developers who are building on top of your platform who may compromise the level of security that you are comfortable with?
PayPal is in charge and responsible for the security of the consumers, period. Meaning, if it takes vetting the application, the developers and everything, at the end of the day, we are responsible for that. We take that into account. Meaning, anything that goes on the web, anything that goes on the wire, when it comes back, it's the paradigm of rogue secret agent who is in a rogue country. Whenever something from that agent comes in, you got to verify, is there a gun in his head or is it telling the truth? So you assume that everything is completely unsecure. You treat it as if it was rogue. Now, that said, there's a difference between a big partner, there's a Bling Nation, that have stake in the game, than Hadi the hacker who just says, hey, I downloaded this application, it's kind of cool. Now, that is between PayPal and the developer and the application. There's another player which is more important from our perspective, our common perspectives, the user. Our objective is to make sure that regardless of what kind of service we expose, the user experiences the same safety and security. How we deal with that, it's dynamic. It's not a static rule as to, if you're a developer who's like brand new, we don't trust you. We might take that into account, but Bling Nation or an application that is sitting here who has been around for a long time may be a bigger target of hackers. So you can't just go ahead and assume based on static rules that these applications are good, these are bad. You have to make those decisions dynamically. Remember, it's data-driven. The more data you have, the more characteristics of the users, applications, developers, players, transactions you have, the better you could make decisions. The less friction you have for the users. People who work at PayPal, they know that friction at PayPal is the F word. We don't like our users to experience friction. Does that make sense? Any other question? Have time for another question? Just one more question.
Right here. So,
yes, sir.
In the web payment model, you guys redirect the users to a PayPal server, and that's where the users enter their credentials.
Yeah.
In the app world, though, you do not redirect. So the users enter the credentials on the UI of the app, and that is spoofable. Mm-hmm. What guidances or what tips do you have for app makers so that, or the users themselves, right? There are no visual indicators of trust that the users can trust in an app. What do you suggest?
Yeah.
In these
so first, it's not completely true. For the mobile, if you go through the mobile web flow, it is the same thing, but it's just a mobile driver. But the question, foundational question is, users enter their credentials on the PayPal web server because they trust it. But now users are entering these credentials inside an app, in-app payment. There are a couple of ways that we do it, meaning it is, remember, since the execution environment is not trusted, PayPal application, the rest of the applications, your applications, everyone is the same. There is no notion of more trustworthy application yet on any of these platforms. I hope I see that. So we have to treat it as completely untrustworthy, meaning at some times, maybe when PayPal realizes that some applications have bad reputations, there are some activities in some instances of application in some areas, that information we have in the back end. For those, maybe we will require a alternative method of authentication. There are a couple of other layers that we have, meaning we could disable remotely the payment functionality. If there's a problem, then we don't allow the users to use that application. So there are things like this. But it's fundamentally, it's a very difficult problem. It's a non-trivial problem. You can't go ahead and assert a trustworthiness inside an untrustworthy environment. That's the fundamental problem. That's the theoretical problem. The only way you could do it is you can have layered different channels of authentication and verification. No more questions? Thank you very much. Really appreciate it. If there's any other question, I'll be around here. Thanks.